Hello everyone, welcome to the video lecture series of Internet of Things. In today's lecture, we are going to discuss WPAN technologies for IoT, that is ZigBee and HART. I am Professor Swati Suresh Pawar. Before starting with today's lecture's content, let us revise the contents of the previous lecture. In previous lecture, we have studied WPAN technology for IoT and we discussed IEEE 802.15.4. Now let us discuss the ZigBee. ZigBee, ZigBee architecture. ZigBee resides on top of the physical and MAC layer defined in 802.15.4. Physical and MAC layer provides the functionality of OSI physical and link layer. The figure shows the ZigBee architecture. Application support sublayer, that is APS. APS handles 64 bits IEEE to 16-bit ZigBee address mapping. APS routes the network layer message to suitable application object. Each application object is identified by endpoint ID. APS maintains a local binding table that holds record of remote nodes and endpoints registered to receive message from local endpoint. APS also handles acknowledgement, retry sending messages if not received, and data duplication. ZigBee device object, that is ZDO. ZDO is a special application running on endpoint 0 and manages the state of ZigBee nodes. ZDO initializes the APS, NWK and security service provider. ZDO provides interfacing between the application object, ZigBee device profile and APS. ZDO manages security policies and security configuration of a device provided by a security service provider. ZDO gathers configuration information from endpoint applications and provides device and service discovery. ZigBee Cluster Library, ZCL, was added late in ZigBee architecture and defines a library of interface specifications like commands and attributes used for application profiles. ZCL also provides functionalities for network interface, group formation, and management. ZCL acts as a common mechanism for application development even with the ongoing development of ZigBee. ZigBee Application Framework. This provides API for ZigBee application and development, and each ZigBee application is appointed on endpoint starting from 1. ZigBee node types. First, ZigBee end device, that is ZED. ZigBee router, ZR. ZigBee coordinators, that is ZC. ZigBee network layer, NWK. ZigBee APS layer. ZigBee end device, that is ZED. ZED works with 802.15.4 providing reduced functioning device. These nodes are battery operated and are not always listening or sensing. ZED has to connect a network via ZigBee router which acts as its parent. ZigBee router, that is ZR. ZR works with 802.15.4 and provides fully functioning device, that is FFD. ZR are permanently listening and are able to route packets once it joins the existing ZigBee network. ZigBee coordinators, that is ZC. ZC works with 802.15.4 and provides fully functioning device, that is FFD. ZC can create a network and can also act as a 802.15.4 based personal area network, that is PAN coordinator. ZC can form a network and can also connect to the existing network and are able to route packets. In such cases, ZC becomes the ZR. ZigBee nodes are not mutually exclusive, which means ZED can also act as ZR and even as a ZC. ZigBee network layer, that is NWK. NWK provides multiple routing of data packets in a mesh network which is not available in 802.15.4. ZigBee uses short address allocation to nodes ranging from 0x0000 to 0xFFF7. ZigBee coordinator node uses short address 0x0000. ZigBee supports two address allocation modes. Stack profile 0x01, in which address is allocated based on the position of the node in the mesh or tree topology. Each potential parent node is associated with subblock or network address, among which address is allocated to the requesting node. Stack profile 0x02 uses random address allocation mechanism, and any address conflicts are detected and resolved by the ZigBee, which requires additional computations. ZigBee network layer frame format. Figure shows the ZigBee NWK frame format. ZigBee network layer frame format, which shows the table shows the field and field size in octets, that means bit. Frame control is of 2. Destination address is a 2 or 8. Source addresses are 2 or 8. Radius is 1. Sequence number is 1 and payload is variable. Frame control bits are used to define various parameters like communication type, that is unicast, multicast, broadcast, security enabled, disabled, route discovery enabled, disabled, source IEEE address is specified or not, destination IEEE address is specified or not. Address field can be 2 or 8 octets to handle 16-bit ZigBee address or 64-bit IEEE address. Radius defines the maximum number of hops allowed for the packets. Sequence number is the packet counter. Payload carries the APS and NWK layer commands, if any. ZigBee APS layer. APS manages and provides support for local applications and also provides mechanism for developing and interconnecting ZigBee applications. A ZigBee device can implement multiple applications on the same 802.15.4 address. So, to differentiate between applications on the same address, ZigBee uses endpoint to define applications. It is same as port number in TCP/IP network. As endpoints is described by simple descriptor. A simple descriptor has endpoint number, application profile ID, application device ID, application version ID, list of input clusters and list of output clusters. The simple descriptors of an endpoint can be retrieved by any node in the network using simple descriptor request command, which is simple underscore DESC underscore request, that is REQ. ZigBee APS layer format. Figure shows the APS frame format. ZigBee APS layer frame format. Figure shows the field and field size in octets, that's in bits. Frame control is of 1 bit. Destination endpoint is of 1. Cluster identifier is of 1 bit. Application profile handler is of 2. Source endpoint is of 1. Counter is of 1. And payload is variable up to 80 bytes. Frame control bits are used to define various parameters like frame type, that is data, command, ACK, delivery mode, that is unicast, multicast, broadcast, security enabled, disabled. Source endpoint is 8-bit long and specifies the originator of the frame. Destination endpoint is 8-bit long and specifies the recipient of the frame. Cluster identifier is 8-bit in length and is used to identify the cluster that is used in the binding operation of ZigBee coordinator. Bind request function is used to form a cluster using ZigBee coordinator, that is ZDO. This field is present for data frames but not for command frames. Application profile identifier occupies 2 octets and specifies the ZigBee profile for which frame is intended. This field is used in data or ACK frames only. Payload contains information about the individual frames. Now HART. HART stands for Highway Addressable Remote Transducer, which is an open hybrid, that is analog plus digital communication protocol. HART is popularly used in industrial automation for various devices. HART protocol can be used to provide both analog 4 to 20 mA and digital signal, which provides flexibility to product, which makes it a superior communication technology. HART's basic working can be explained using following points: communication modes, frequency shift key, HART network, HART commands, HART packet structure. First, communication modes. HART works in two communication mode, that is master-slave mode, and second is burst mode. Master-slave mode. Master is the main controller communication device that maintains other slave field devices. Communication is initiated by a master device. There can be two types of master nodes. Primary master node can be a PC, programmable logic control, that is PLC, or a distributed control system, that is DCS. And the secondary master node is usually a handheld device or PC. Slave nodes act based on commands from primary to secondary master node. Slave device can be actuators, controllers, or transmitters. Burst mode. Burst mode is used for faster communication, which is available in some HART devices. In burst mode, the slave devices to continuously broadcast a standard HART reply message as instructed by the master node. Once the master instructs the slave to stop bursting, slaves stop bursting messages until that time master receives the message at the higher rate. Frequency shift key, that is FSK. The HART works on FSK principle and is built on the Bell 202 telephone communication standard. Figure shows the analog and digital signal in 4 mA and 20 mA band. As shown in the figure, the digital signal is made up of two frequencies, that is 1200 Hz and 2200 Hz, representing bits 1 and 0 respectively. Simultaneous analog and digital communication is provided by superimposing the sine wave of these two frequencies on the direct current, that is DC analog signal cables. The 4 to 20 mA analog signal is not affected as the average value of the FSK signal is always 0. The response time of the digital communication signal has of approximately 2 to 3 data updates per second without interrupting the analog signal. 230 watt of minimum loop impedance is required for communication using HART. HART network. HART has two types of network configuration: point-to-point, multi-drop. HART device can operate in any one at a time. First is point-to-point. In this mode, the 4 to 20 mA signal is used to communicate one process variable and the additional process variables. Other device data and configuration parameters are transferred digitally using the HART protocol. The HART signal doesn't interfere with the normal working of the 4 to 20 mA analog signal. The digital signal of the HART communication gives access to secondary variables and supplementary data that can be used for maintenance, operations, and diagnostic and commissioning purpose. Multi-drop. This mode of operation requires only a single pair of wire to be operative. This operation mode also uses safety barriers along with an auxiliary power supply for up to 15 field devices if applicable. All process values in multi-drop operations mode are transmitted digitally. Polling address of all field devices are greater than 0 and the current through each device is fixed to a minimum value, usually 4 mA. HART commands. HART has a command set divided into three classes for uniform and consistent communication between all the connected devices. The command type contains three classes: universal, common practice, and device specific. Universal provides access to normal functionalities and must be recognized and operable with all devices using HART protocol. Example: read current output and percentage of range, read manufacturer and device type, read device range values, etc. Common practice. These commands provides functions implemented by many but not essentially by all HART communicating devices. For example, write sensor serial number, perform master reset, perform self-test, etc. Device specific. Functions which are unique to each field device are included in this class. Each command access setup and calibration information. Also, information about the construction of the device can be accessed using these commands. Example, bulk characterization, bulk set points, travel limits, local display information, etc. Wireless HART. Wireless HART is created on the original HART communication protocol and user layer. It is a data link protocol. Wireless HART operates on the top of IEEE 802.15.4 physical and implemented time division multiple access, that is TDMA, in its MAC. It uses advanced encryption to encrypt the messages and also calculates integrity of data, which offers reliability. Wireless HART offers three types of security mechanism, that is end-to-end, per hop, or peer-to-peer. End-to-end security mechanisms guarantees safety from sources to destination, where per hop mechanism security is up to the next hop only. Summary of today's lecture. In today's lecture, we discuss the WPN technology for IoT, in which we discuss the ZigBee and HART. Thank you.